programming language, and we started learning REST yesterday, and we had covered quite ground using Rust book. So let's just before beginning to our day two, let's quickly recap with whatever we covered yesterday. So, and as you can remember, I also created notes on the Medium, and then I'm creating these notes. I'm also sharing it on Medium. So if you want to get access to these notes, you can probably subscribe to me and receive the notification whenever I'm publishing these notes. Okay, so yesterday we looked into Rust, installed Rust in our Visual Studio Code. We also looked into what macros are, what functions are, what cargo is, a package manager for Rust. We already know what package managers are, right? And we also looked into certain command to build our REST application with cargo build. And in case we want to directly run the application, we can do a cargo run. There are also ways, as you would have saw yesterday, that cargo generated quite a bit of additional files, some other data files, a few other directories like target, where the binary was actually residing. So instead of that, if you just want to run for errors or compile time errors, you can just go ahead and use the cargo check. Then we also looked ways to define variables as well as declare the variables. And we also saw that we have a keyword called let that helps us to do that. And by default, these variables are immutable. As I was also seeing that yesterday, as I mentioned that instead of doing this, they have done a keyword called var. It seems that there is another or a const. So it seems that there is a keyword called const to define the const, and we will see how that is different than this immutable way of defining variables. Then there were associated functions. So we were also we also saw that standard library had certain classes, and these classes have some utility functions, and these functions are called associated functions. Right. So we also looked into enums. So we saw a result type, right? So we were, I guess, parsing string, and it was returning a type or enumeration called result, and based on what result we had, what variant of that enum we had, we were kind of checking onto either it's okay or error, and for that we were using a match clause or a match expression. It was kind of a switch case, which will kind of switch on to multiple arms, and based on that, whatever comparison we made, it will execute that particular clause. All right, so we were also using println macro and use these placeholder to fill these with the values in the println. All right, so this was from yesterday, and let's get started day two of this Rust programming language. All right. Okay, so let's head over to Rust programming book, chapter 3. All right, so here in chapter 3 it says that we're covering almost common programming primitives or syntaxes or whatever concepts that appear in almost other languages. So number one, keywords. As we saw yesterday, that we had used keywords like let, right, match, mut. So there are a few other keywords. So if you are more interested all those lists, you can go to this keywords, right? So you have as is the way it looks good. You have brick. We already saw this yesterday, right? Whenever we were receiving a correct input that matched the secret, we were breaking from the loop. This will be looking into there. Yes. We also saw continue. If for some reason there was an error from the input, we were just continuing the loop. So this was also common to some other programming languages. We looked into create nothing but external libraries that we can import using use keyword. We saw FN, I guess. Right, so there are multiple other keywords. I guess we also saw use and use this. All right, so let's head back to chapter number 3. Continue. All right, so yesterday we were looking into variable and mutability. So by default, variables are mutable, right? So already provides a safety by default. So when a variable is immutable, once a variable is bound to a name, you can't change that value. All right, it's self-explanatory. I don't think it requires much of explanation. So it says let's generate a new project called variables in project directory by using cargo new variables. All right, so let x equals to 5. We just prints that 6, and as you can understand, so we are not going to write this self-explanatory. We just that by default this is immutable, and we want to re-initialize it. That's going through interestingly, it throws a compile time error. So I guess if we do a cargo check, this should already be throwing us error. So let's try this, or not. Let's leave it for now. All right. So this, I guess, again, complete description of what happened here. All right. So next, if you want to kind of initialize this, you have to make it a mutable variable. So then it compiles as expected. Okay. So now variables are done. Another thing is constant. It's interesting that they have created two types of similar concepts like immutability and as well as constant. My initial impression was the constants. We have directly variables are constant, and in order to make variable, you are going to supply a mute keyword, but they have entirely different concepts. So like see, want to name and are not allowed to change, but there are a few differences between constant and variable. Let's see. You are not allowed to use mute with constants. Okay. Constant aren't just immutable by default, they're always immutable. Okay, so variables are, so I will also open medium meanwhile so that I can create a story for this one. So Rust 002. Right, so yeah, where were we? So constants aren't just immutable, they're always immutable, right? So unlike variable, you cannot create a variable which is immutable and later decide that okay, I need to reassign it. Then I can just add a mute keyword. So that's not allowed. Mouse keyword instead of let keyword, and the type of value must be annotated. And the type of value must be annotated. I'm not sure what that means. Let's see. We are about to cover type and type annotation in the next section. Good. Okay, let's skip this then. Constant be declared in any scope, a global scope. Yeah, so it doesn't matter because their value is not going to be changed. So we do not have any any problem where we want to safeguard that particular constant against threat or against the scopes. Large constant may be set only to the constant expression, not the result of value that could only be computed at runtime. All right. So if this value is pre-computed, for instance, so we can use this. But if there is a variable here, y into x, we are taking that as an input from the user, or that gets resolved during some execution, then this is not allowed, right? All right, so again, I guess this is common to all the programming language, how constants are useful and how hard coding allows you use those constants throughout the application life cycle. All right, next is shadowing. Again, this is a common concept. So once you define a variable or declare a variable, again you declare a variable here, it kind of shadows this particular x. So this scope, this particular x is limited to this. So let's try to guess it, what exactly this will print. So here it should print x into 2. I'm not sure. Have you covered the default values somewhere? Or the default values? I don't think we haven't covered. For instance, in Golang we have default values for each data types. For instance, we have declared x. Let's run this. As well. So 5 is 6, and 6 into 2 is 12, and here it will be 6. All right. So the scope of this is limited to this particular piece of block, and whatever execution or expression evaluation happens here for x, it's limited to this particular scope. So this is same than all other programming languages. Yeah. So I'm not going to explain this because it's whatever right now we kind of went ahead and looked into this piece of code. It's exactly the same explanation. I guess they have given it here. Okay, he says that shadowing is different from marking variable as mute because we'll get a compiler error if we accidentally try to reassign to this value without using a let keyword. By using let, we can perform a few transformation value but have the variable be immutable after those transformations have been completed. All right. Okay, then I'll skip this. This is again same sharing concept, similar to almost all the languages where you have the variables visibility limited to this particular piece of scope. All right, let's see that was the problem here. So this is a mutable space variables type. All right, let's check here. All right. So we need to declare a new variable here if we want to calculate the length of this one, because len is, I guess, essentially an integer or something. Yeah, len is some use size, it seems, but this particular piece of code is a string, I guess, so you can kind of mutate the type of that variable. Right. Again, we learned how to do type casting. Probably that will help to typecast in case we want to do that. All right, let's go to the data type. Yeah, today it will be slightly boring because it's kind of common to all programming languages, different data types and different ways of declaring that those data types um, in Rust. So let's see that there are two data type subsets, scalar and compound. So something like primitive in other programming languages, and advanced, I'm not sure what's the other word. So let's also use this scalar and compound. So there are two types of data type. Right. So this particular piece of code we already saw. Right. Uh, so we are just parsing this. In our code, we also had primitives. We are passing this to unsigned of 32 bits, and this is again a type assertion. In case this is not of this type, then it panics in the runtime. It seems like it has some issues. Well, looks like it's not able to understand what 2 is. So if we don't add the type annotation here, Rust will display it, which means the command know about which type we want to use. I guess you're already unsigned integer. So this is asking for 42, or this is asking for this guess. I'm not sure about this. Consider guess a type. Oh, bias in this particular piece. So slightly error here. So here in this particular piece of code, they have not supplied this data type. That's why they are returning an error. But I guess this piece of code is fine for now. Scalar represent a single value, as you would have already guessed. Yeah, I just copied 4 scalar we have. So we have float point, we have integer, we have boolean, and we have chars or characters. So integer, I'll just skip past this. We saw this, and we also have. Oh, now I guess what is the type annotation, right? In the previous 3.1, there was a statement on the type annotation we will be covering later. So, but by now we have some understanding on what a type annotation is. Okay, integer. So there are different integer types as well. So you have 8 bits, 16 bits, 32 bits, 64 bits, and 128 bits. Also, you have both signed and unsigned, and say that I means unsigned and U means unsigned. So I'm not going to delve deeper into these signed values and how you can store it as whose complement or whatever was complement. So that's an architectural side. So if you're more interested, you can just go head over this one. Yeah. So there is a section on integer overflow. Let's go to this. Why not? Let's say you have a variable of type u8 that can hold values y8. That's 2 to the power 8. That means 256. If you try to change the variable to a value outside that range, so it's 256, integer overflow will occur, which can result in one of the two behavior. When you're compiling debug mode, Rust includes check integer, and that causes the program to panic at runtime. If this behavior occurs, Rust uses the term panicking when a program exits. We'll discuss panic in more depth in. Okay, so in case you have this integer overflow, you would receive a panic at runtime. Or if when you are compiling in freeze mode, Rust does not include checks one, and that causes panic. Instead, the overflow occurs. Rust perform 2 complement wrapping. In short, the value greater than the maximum value the type can hold wrap around to the minimum of the value the type can hold. Alright, so this will be wrapped around to 0. Why? Yeah. So 256 will become 0, 257 will become 1. Okay, so there is a wrapping around. So always remember this when we have integer rows, so we may get slightly different results, right? So in case you want to explicitly handle the possibility, so they have provided some ways. In all modes, return none. Yeah, I'm not sure what these are. Probably we will see that. Or probably we can check this wrap in all modes with wrapping underscore. Can try this. Alright, let's try this. So let's go a step back and run a cargo. Well, first I'll clear this. Run cargo new variables. Yeah. cd variables. So just close these all. And then I'll head over to source code. All right, let's define a variable user input. We will provide type annotation it, and will provide okay, that's already provided name. And I guess this was this one. Yeah. And now let's take the input from the user. For that we have to use std. I forgot the user. Let's take it from here. So stdio. And what else? We can also take the input from the user. So for that, so it reads line. Yeah. Now we are going to parse this. Let's parse code. This was the parsing code. So let's use this weight instead. Yeah, I guess this. I'm not sure whether wrapping is required. I'm not sure what exactly is this. But if okay, then we can just print this number. Println number received is none. Else, in case of error, we are going to print. So we have captured the pan. I'm not sure whether this will return. Do I need to do this, or will just do an input? Yeah, and I'll just make it mutable. It's not required. Oh, this is for gas. Yeah. Yeah. So I need to give a number that's greater than 255. So we are going to build it with our release. So let's do that first. So cargo build and this master data. Okay. the snowman is in here. Oh, all right. So this is a match. Expected weight. Oh, I guess this one is. So what is this? Okay, I'm not sure. So this is a lambda. So whatever result we are expecting out of it, it's going to be here. Expecting U8. Yeah, this is U8. What's the problem? Expected U8. Oh, let's print this maybe. This is something. Let's try this. Expected U8. Maybe I need to find this. Yeah. Let's use this here instead of defining there. And I will just remove this. Good. Yeah. I am not sure. So let's go back and revisit this. Did we define this? Yes, we have defined this. Yes, and we are reading from command line. Once we have received this, that's mute. And then the next one is to match it. This one is the match expression. So this is the match expression, and either is okay or what exactly is wrong here. So maybe I'll just print this mismatch type. Maybe this is 32. No, it's not even taking 32. Something is actually. Oh. It doesn't make any sense. placeholder. Yeah, not found in scope. Is there in scope? Interesting. Cargo check. Expected U8. Maybe just shows you 32. Oh, understood. So it's going to just, if it's okay, then it's going to assign this particular to this. So this guess will be equals to number. Yeah, gonna print anything here. Okay, so now concepts are clear, right? All right, so print all in the number in case we have an error. I guess it will again throw an error because it needs that particular type. So I'm not sure what we are going to just remove this error. So I guess should panic with U8. Oh, unused variable. Okay. So I will be able to just print this. Print OM. Okay. Pattern. Okay, so that ERR is required. If that's errors, just return it as 0. Yeah. So go run. Correct reading 45. That's fine. So I'll give this bigger number 0. Right. So we saw that this overflow can be captured in case there is an error. So in that case, we can set this number to any number that we would like. But I was also looking into in scenarios where I can print something in case error is, but I guess this match arm depends on assignment. So it's okay, then you assign this variable to this one or this one. I was trying to do something like this. All right, so this is because this particular piece returns a type result, and if that result is, I guess that will be a function, so you can assign that function to this one. Yeah. All right. So this is a bit interesting. All right. Let's get going. I guess we understood some concepts here. So here, arms of match are nothing when we are assigning a variable. So this particular value is kind of assigned to this particular. So here, this ordering dot less, it results type of a result. So that can be a function. All right. Okay. Floating points. Again, we have annotation. We have defined the variable and annotated it with 3.0. What is F64 and F32? Rust also have two floating point number. Decimal floating point type F30. Again, these are depending on the number of bits. So that we have 32 bits and or 64 bits. So just copy this. The default type is 64, so that's good. All right, numeric operations, so mathematical. We can directly store this variable using let. The calculation can be stored in difference using let multiplication. We have division. We have another division, so we can also have a floating division. Yeah, I'm trying to run this, but it seems that the VM is not responding, so this is not working. Okay, so we have an appendix, so that provides all the operators. So this one we also use for macro expansion. Also use for bitwise. Okay, it's a not. Again, all other mathematical operations. So this particular function enclosure return we already saw yesterday on the result type. Yeah, okay, but that is an equals followed by greater than operator, so that is different than this one where it is. So operator that we saw for the results still seems okay here. Part of mathematics syntax. Okay. All right. Let's go. Boolean again, the same, a true or a false. Character type, again, a single character. Oh, it's interesting that we can also have a sky value here. Scalar value. So cat type is a 4-byte of size represent, which means it can do a lot more than just in a sky. All right. So now, I guess primitive is covered. We have covered an integer. We have seen sign and unsigned. Sign is represented by I, and sign is represented by U. We also saw integer overflow. That's kind of improved our understanding of this match arm. And here that I was trying to print something, but remember that there is an assignment over here, and based on what arm gets executed, that gets assigned to this particular piece of expression. I guess let's try this one. I guess if it's okay. So I'm not assigning anything here. So if this is the case, then I guess I should be able to print this value over here. So we'll just print a value, and if it's an error, then I can simply say that error occurred. Let's try this. The previous error cannot infer type. Or if I do this, so I can just have value received. Okay. Okay, so for value type inference, I guess that particular annotation is required, else this doesn't execute. But it will come into later once we have more intuition about Rust programming language. Right now, I guess we are still lacking the intuition, but I guess that grows as we start developing our code. Right. So for now, this looks okay. I also mentioned that yesterday I'll be putting it in GitHub, but I haven't done till now. Wait for it. Alright, so I will kind of take some break, and then I'll be back in say 5 minutes. Alright, so see you in 5 to 10 minutes. All right, let's continue. I guess also let's recap what we were discussing with chapter number 3. We were looking into variables, immutability, and mutability. We also saw new keyword constant right there. And we also saw that constant can be assigned to an expression that can evaluate. Um, um, and apart from that, we also saw the concept of shadowing and closure and how this particular piece of expression was only limited to this particular block. Data types, we saw all the scalar data types or the primitive data types like string and float. One more was there, two more were there, boolean as well as character. We also saw that integer overflow, and this also helped us to intuitively understand how this match arms works. And as we are providing an assignment or a value to this particular piece of or this particular variable, so this necessarily should be a type of this variable, and it's not like an expression or an expression that can evaluate to this particular variable. And I guess right now we are far more comfortable to use mesh than we were yesterday. All right. So next one was Boolean. Boolean is same like other programming language. Um, so again with the value true and false. Character type, again same like other programming language with single quotes, and your strings are quotes. Now let's start looking to the compound type. So compound type, as I can understand, or without reading, these are something which can have more types or more values, as it says, grouped into one type. So if you're coming from C, you would be having struct, or C++ class, Java has class, Golang has struct. It seems that it has a few more concepts. I'm not sure whether arrays is a compound type in other languages. Here it seems arrays are the okay. So arrays are the compound types. Oh, it seems that it is not talking about struct and class. It's talking about collections as such, collections which can store multiple scalar values. So in fact, you can compare it to like arrays, or Java has arrays, sets, hash, map. Tuple type. A tuple is a general way of grouping together a number of values with a variety of types. Alright, so you have defined a tuple, and in one assignment you have defined different tuples and also annotated it with its data type. Alright. The value to binds to the entire tuple because the tuple is considered a single compound element. Alright, to get the individual values out of tuple, we can use pattern matching to restructure a tuple. So tuple is this one, and let's okay. So we have just deconstructed this tuple, and the values will be assigned to, I guess, x 500 y 6.4, and 1 is z is assigned to 1 is assigned to z, and I guess this will also keep its data types, whatever data types we have defined. I'm not sure if we are to, let's try this, do the same thing with this particular piece of code here. Okay, we can on this here, but this doesn't execute most of the time. Oh, this time. surprisingly this executed. Okay, so this particular piece of code here, this particular statement, it's called restructuring. I guess it's similar to some other programming language. I'm sure whether we have restructuring similar to this one in Golang, because what we have is, say, a function return type, which has multiple return values. You can assign it directly to this type of operation, or you can also kind of declare xyz equals to these values. I'm not sure whether we can do a similar grouping of the numbers. We can also access the tuple element directly by using a period. Okay, so you also have a access keyword, I would call it. So you can access the values x dot 0, x dot 1. So it's similar to the array index. So these are nothing but indexes of these values inside this tuple. All right. Do you want me to copy and try this? Let's try this. Maybe we can do some other thing, because last time we kind of have more into understanding on. So let's clear this. I'll expand this one. Cargo run. Okay, cargo new and tuple cd tuple, and this should be here. Right. Oh, where did we create this? We created inside this one, so no issues. We'll just use this. So let's create a tuple with let tup equals to some values. Can we do a string? 3.4. Side in this. Print this. I'm not sure if I need to install more plugins for this one, because still IntelliSense is not that great. Let's first just print this complete tuple if we can. Yeah. Cargo run. What says can be okay. Doesn't implement. Okay, so in order to use this println placeholder functionality, it needs to implement this particular. I feel this would be an interface there. I'm not sure, so we haven't looked into how an interface works. So what we can do is do 2.0. What is it? Okay. Semicolons. All right. So it also gave us some additional information. So with this we already covered. In format string, you may be able to use for pretty print instead. All right. What is it? Can we do this with just a tuple? But I don't think this particular doesn't give us the implementation of the interface, so I don't think this will do anything. Oh, that's interesting. All right. So we need a few other form specifier along with this placeholder, and in our case we were able to get this with colon and question mark. So just copy this as well, and I'll be sharing all these notes later on. Okay, so this I'm able to print this tuple. Yeah, so let's move forward again. This is almost all program language has an array type. I'm sure here. Oh, I guess difference between array and tuple, yeah, is that tuple is of can have multiple data types grouped together. Array would essentially be having groupings of similar data types, right? Oh, so there is also a notion of where you want to actually allocate your memory, and it says that arrays are allocated on the stack rather than the heap. I am not sure. All right, so let's see this in the latest section. Do we have anything on heap that says that whether this particular on tuple where the tuple is stored in heap, or it it can store somewhere. Another thing is we missed that tuples have pixel and once declared they cannot grow or shrink. Okay, so tuple also has a fixed fixed size. Okay, we read about restructuring. Okay, there another point to be noted. The tuple without any values is a special type that has only one value also written. Also empty parenthesis. So this is a special tuple. I'm not sure. The type is called a unit type, and the value is called unit value. Unit value if they don't return any other value. I'm not sure how this is useful. Maybe in case of function return type. So maybe there is an error record and you want to return a default tuple. So maybe you can do that. Right, I'm not sure. Maybe we would get something more of this one later on. So nothing about the memory allocation of the tuple. So I'll just make it a note and maybe where tuples are stored. So since this is not mentioned, I assume that this may be being allocated on the heap, but let's see that later. Another way to have a collection of multiple values is with array. Yeah, so this is common. Let's read this particular paragraph here. An array is as flexible as a vector type, so it seems that there is another type called a vector. Similar collection type provided by the stand that is grow or shrink in size. All right. So again, I guess arrays are also of the fixed size, and they have all the data of same data type. If you're not sure whether to use an array or vector, chances are you should use a vector. So I guess we are very far from reaching to the vector, so that's covered in chapter 8. Okay, so if you know the number of the values in the default, you are probably going to use 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 an array. So if you compare this with Golang, there you have the concept of slices and arrays, right? Slices are abstraction on arrays, and in case you want to define a slice and you already know the size, it's best to define it according to the size of the data it's going to hold. Else, you know that you would be running into running into uh, um, some uh, some additional costs, like your underlying array gets doubled, and you have additional cost of copying those values to the newer arrays. Right. So here it says that if you know the size in advance, better to use the array. So it seems there is another type annotation here. So I guess that's size 1, 2, 3, 4, 5 followed. Sorry, it's signed int followed by size, type of each element, semicolon, and then the number of elements in the array. All right. So there is a new way of defining this one. I'm not sure if you define 6 and provide that. I guess this will throw compile time error. Right. Can we try this? So let's used. I'm not sure what. No, I'm not sure what that was, but it didn't look like some macro. I'm not sure. All right, let's put that at 6, and we will just copy this. Yeah, we haven't seen in detail what exactly this format specifier is. All we were able to get it from our error logs, and it seems that it helps us to print this out. Now we will try to do same thing with an array, but this time this array, right now we have stored 5 elements, but we have cleared it as the size 6. So yeah, so we have this find list as 6. So we do not the concept like this will be auto assigned to some default values. So it seems that if you are declaring the size, you are going to insert that many number of elements. Yeah, and can we do a number that is less than this one? Obviously, this will again throw some error. Yeah. All right. Okay, so this is kind of a common expression across all the programming language, where I'm not also sure all, but most of what I have gone through. So you have index in the square bracket. Okay, so I guess we missed this part. So what is, so you can also to contain the same value for each element, specifying the initial value followed by and the length of the array as shown. Okay. Oh, all right. So this is also good because what we are trying to do is auto assign some default values. I guess use this expression that has a let followed by the value followed by how many times you want to repeat this particular value. So this will kind of compile to this particular piece of code here with 3. So let's also try this. I'll print this. Okay, just go back to 5336. All right. And we also mentioned that the default mm, variable type is immutable. So I'm not sure whether that's also true for arrays. I think it should be. So let's try to change a value inside the array. Let's try to set something like a of, this one is a of 2, 0, 1, 2, to something. So it's sign integer, so I can do a, sorry, I can do a -3. And then again, if I print this, yeah, because we already know that the values by default are immutable, I'll just make it mutable, and then I see that the value in the array is changed. Alright, so this makes sense now. Let me check the chat if somebody is there. Let me know if there is anything I am saying wrong. I am learning Rust. I'm new to Rust. Alright. That is also again that's common to index out of bound, similar to that. So enter an array index, it index again, it takes the input from the user for the index, then parses it, converts it to an unsigned, because all array indices start from 0, so definitely those are unsigned. And then element, we read it and then just print this out. So if we provide an index that is out of bound, then this is the panics during the runtime. Okay, so to fix this, what we are going to do, we are going to expect, right? And we can have a match here, in case the result, can we do that? Right, so let's try to do that. I'll just copy this from this one. I'll continue the same program. Alright. So this would need an stdin. Use. I'll just copy it from there. It's just the stdio. So this import is not yet in my, yeah, if it's some other programming language that I'm used to, then I will probably write it without using the end license. But right now I'm still trying to grasp this. So what I'm trying to do is, I'm not sure how do we comment here. I haven't tried this one. Yeah, so it's fine. All right. There again, we have defined this array with 1, 2, 3, 4, 5. Enter an array, and here we are telling the number, right, to pass it. So what I'm trying to do is I'm trying to make use of the result enumeration such that if my values is out of bound, then I would I would simply terminate this particular piece of code instead of uh, panicking at line number 35. Right. So what I will do is I will just match it, but and then I guess I can compare it. What was the syntax? Sorry. Guess same. All right. So parse would return only these variants. So let's. I'm not sure why I removed that. Right. All right. So we can do a compare here. So for that, I need to import standard compare ordering. I think it's called crate. Crates are the external libraries. These are kind of crates were internal to REST code libraries. I'm not sure whether it's right to say that this particular piece. So I'll just no. Right. So syntax for comparing again. So we have index dot compare with, I guess we need to compare it with reference to that value, kind of, if I understand correctly, where it is. Compare with the number. So I need to compare it both with 0 as well as 5. So I'm not sure whether this expression would be able to do it in one way. So I will just compare it to max size, because I guess this particular piece, as we have assigned it to U size. What is U size? We covered U size, I'm sure. Let's go on to the types here somewhere. The data types. U size, U size. Okay. U size type depends on the architecture of the computer. I believe that's U size. This one depends on the architecture, but I will assume it's an unsigned, so that line will probably take care of anything less than 0. So what I will only compare here is the max index. So let max index equals, what's max index for now? These values are 5, so max index is 4 for me. So max index right, so I'm going to just match this. So I need to just match it with the greater one. So if the ordering dot creator or scope resolution of control Z. Yeah. So and I just exit. I'm not sure whether we have this exit here or the exit 0 thing. Let's see that, or we can just go return. I'm not sure whether still haven't seen. So we will just print index out of bounds. Right, so parameters, project variables, what is it, both, oh, it was already there, that's fine. Alright, let's do cargo run quickly. So, method not found in use size. Interesting. So what I'll do is I'll just do u it. Oh, what is it? U8. That's it. For now, I'll just keep it as U8. That's interesting. Okay, so I will also annotate it. So method is also not found in U8. It's U32. That's summer. Cannot index to a value type U32. Okay, so the data type for these values is says it's an integer. So let's try whether integer has this method or not. I need to look into the docs, it seems. I didn't know that we have this integer data type as well. That's fine. So we do not have an exit. So that should have been inside this one, even if we have the exit there. I'm not sure. So it seems that the use size is not there. I'm not sure why. We have use size I guess because I'm for instance working on one and its instruction set are slightly different. So the data types that we are using to store these variables is different and depends on the archetype of this particular program. So what else we can do? I guess we can also use make use of simple if else layer. I'm not sure if somebody is watching. So I guess we should be coming back to this. I guess if else right now it doesn't seems to work with U8. Obviously this seems to use an integer data type, and we have not still touched base on integer data type. So what should we do? Let's come back on this one. So I'll just comment this out. I guess we do not have yet that much of understanding on Rust so far. So I'll just comment it out and probably will come back once we have a bit more understanding on on the data types as well as arrays. So let's get back to array. All right, we have covered this one. Array elements we have already covered. So this one we already saw. But what we were trying to do is kind of use match, uh, use the match so that whatever index has been inputted does not go outside the bound. All right, functions. We saw macros. We already saw function as mean that entry type to this particular REST program language. All right, so from there we can again call another function that's common to any other programming language. Name of the function followed by parenthesis. Again, you have this keyword fn. Java is func. Few program language do not have any keyword. Just go with maybe visibility keywords followed by run type, or just a name signature of the functions, which include the parameter as well as the run type. So I'm not running this for now. Maybe once we have slightly complicated function, then we can go ahead and execute that. All right, so this is what makes function a function, because it can function certain piece of input, and that input is the parameter. And here again we define a variable followed by a colon, and then its type. So here the type of this is an unsigned 32, so I'm skipping it. That's self-explanatory. And here we have multiple parameters separated by comma. I would be interested to see if we have variables of same data types. This is how they are grouping this. In Golang, they will be just defining a list of those parameters, and then in last you will have the data type for that particular group which has the same data type. Okay, I'll also skip past this. Statements and expressions. So whatever is inside a function is a statement. An expression, I guess, something that's get evaluated is called an expression. Let's see what we are talking about, because REST is an expression based, has an important distinction. To understand other languages don't have the same distinction. So let's look at what statements and expression are and how the difference affects the body. Statements are the instructions that perform some action and do not return value. Yeah. So expression evaluate to a value, and statements are just instructions that I guess I missed to copy or some of the notes. Maybe I'll do it later, but I'll definitely share the notes onto this medium. Alright, so we have already seen this. This is so. So does I've not read through this document yet. So let me guess. This particular statement here defines a value or a variable 6 and x equals to y. This means, so I'm not sure whether y will be visible outside this statement, whether we can use y, but it seems that it should not, and it also looks like a function, because this particular piece of what we call expression, because it's evaluated to 6, is wrapped around parentheses. So let's see what exactly. Statements do not return values. So if you this is invalid statement. So I was wrong explaining this. I should have seen this particular icon or whatever emoji. So this particular piece of statement will return an error, because it says that statement do not return error, and therefore you can't assign a let if statement to another variable as the following tries to do that. Okay. Yeah, but I'm interested in executing this because our logs. The good thing about Rust log that I see right now is it also gives you certain hints based on what error are available on the log, so that you can try these uh, these statements or expression against whatever is showing some error. That's nice thing there. But again, these logs should be carefully spit it out if you are in the production environment. So you do not want these. Obviously, these are compiled and error. So that's fine, I guess. All right, here let's run this. So a good thing is we already have, but most of the time this. Okay, so value of y. Again, this is let y is a statement, so it should not return anything. So let x equals 3x plus 1 is 4. So y will be 4. But this is the expression instead, because here we have the evaluation. Slightly confusing. So let's, I guess, read through this particular paragraph or block. Y is equal to y is equal to 6 statement does not return a value. So there isn't anything for x to bind. This is different from what happens where assignment returns the value. In those languages you write and have both and one. Okay, this is not the case in the Rust. Alright, so y is not available outside this expression evaluate to value and make up most of the rest of the code that you write in Rust. Okay, so most of the time you have the expression, which is an expression that value is to 11. Can we pass statement? Alright, the 6 is an expression that evaluates to value 6. Alright, calling a function is an expression, calling a macro is an expression. Okay, so even this lock is an expression in Rust. So this evaluates something. So where this evaluates to 3 plus 1 4. So macro is an expression. Even this particular block or this particular scope is an expression. So here this expression evaluates to 4. That's why your value of y is 4. Okay. Expression not include ending semicolon. If you add a semicolon to then you turn it into a statement, and then it will not return a value. All right. So this is important point to note, and this also gives us slight distinction between statement and expression, right? So here x plus 1 it evaluates, because if we put a semicolon, then the statement doesn't provide any evaluation, and the y, I guess this then throw an error because this doesn't evaluate to anything. Function with return value. Function can have a return value. So again, this particular piece of code has a semicolon, so I guess that's the expression this gets returned. So again, we have return keyword. All right, so it's just a type conversion, that's it. So it returns I32, I guess. Don't name return values, but we must declare the type after that. Okay, so this is just the type declaration. the return value of the function. Okay, so return value is whatever the final expression evaluation is. Okay, that's also interesting. So some quirk of Rust. So it says that whatever is the final expression in this particular function, that will be the return value. So here final expression is 5, so it's the return value. Let's see whether we have multiple return types. 5. So x plus 1. This is the final evaluation. So let's get returned. Comments, skipping. So I don't think there's much in the function. So I guess as we move forward, there would be more stuff. So comments, I'm just skipping past. It's same like any other C, C++, Java, or even Golang has same comment. Okay, so finally we have the if statement, and again if and else block. So it's conditionals and branching. If less than 5, then you print this, else you print that. Remember that do not have the parenthesis. Even code doesn't have this parenthesis, so that's nice to have. If number. Okay, that's kind of Boolean. So whatever expression is after if should evaluate Boolean. So here this evaluates to Boolean. It's either true or false, and based on that, so it's the same like any other language. So I just skip past this. All right. So if it checks visibility by 4, visibility by 3, visibility 2, and then not visible either 4, 3, or 2. Something we tried. So here we have different paths based on what we are trying to check with this number. So here we have else if. So number is divisible by 3. So if any of these paths is executed, then I guess the other path are not executed. So in case 6, which is first is divisible by 3, so this again this just loop executes exits. That's what they are trying to say here. So here the rest only execute the block for the first true condition, and once the final doesn't even check the rest. Right. So this is also true with other programming languages. Using if and else statement, if condition. Okay, that's also. So this if is interesting that we can if in Rust returns the value and that value is assignable. So here if this particular piece of code is returning something, evaluating, or if there is an expression, then that expression evaluates to a certain value, and that can be assigned. So that's something with the rest. Do you want to try this? Oh, we can already try this from here. Okay, so because if is an expression, as it's so it evaluates to something, so that's a new thing. So if it's an expression, just right, so it evaluates something, and when it evaluates something, definitely assign it to a variable. All right. So it's not just a function. Even if a block can also be whatever is the last expression in that block. That's the return type of that particular block. So here I guess this will panic because this will be confused about the data types. I guess. What is let number? So first it is a number, is whatever the data type here, its data type is string. So kind of have a conflict in what data type should this number be resolved into. Yeah, same thing. I mentioned it here. So the compiler needs to know what number variable will evaluate to. So that's why we have this bug here. Now loop, we already used this loop in our guess the game expression, and I'm not sure whether we have for or while loop in it. I guess in the keywords I definitely saw the while to be for. Oh, we also have a for. Then we also have a loop. That's interesting that we have that many new keywords. All right, so it's looping 2 again. We already have a break keyword that we already saw. Break keyword once our guessing gets the right secret and can break out of that particular section of the code. Again, also we had continue. So here we are looping. If remaining, we just break it. What is this? Okay, so in the character, so this is one loop. I'm not sure what exactly is this. So we have something called a label loop. You can optionally specify loop label on the loop we want to use with you're going to specify. So okay, so we have something called label loop as well. So using this, is this particular single quote required with the loop? I'm not sure. And my battery is going to be down. So I guess I'll just take some break, plug in my um, the power source. Meanwhile, I'll stop streaming for like 10 to 15 minutes, and then we will see what this loop label is and why we have this single quotation here with this counting up that the loop level. Hopefully we have answers down in the document. let's get started again. So we were looking into loop section. So I will just try this on my IDE and try to understand what we call this loop label works. So maybe I clear this up. So cargo new loop proc cd loop, and then just open this Rust program. Already copied that, so I'll just copy and paste this. Yeah, install. Alright, this cargo run. So we, as mentioned in the document or the book, we can have a label associated with this loop, and once that loop, and anyways we want to break it from the out loop, you can see that we have two loops running. We can use the break and follow by the label from which loop we want to break, else by default it's going to break from the inner loop. So that's what's happening here. I guess this um, single quote you can have define a variable with this. So I guess that's the only reason we're using this single quotes with the loop label. Returning values from the loops. Okay, so again loops are expression again. So whatever is the last statement that's get evaluated will be the return type. I guess count variable result to hold the return type. Loop is again an expression. Just 20. Why it's 20? Let's see that loop. Counter is equal to counter was 0. Counter is 1. Yeah. So whenever the counter is 10, the value will be 20. This is the last statement that's get executed, and that's get us into this result. So again, that's okay. So we're not going to. But let's see this in our code so that we have all the required code in this one. So last should print 20. Yeah, it's all right. So we also have this shorthand notation kind of thing. So where counter is assigned count equals to counter plus 1. So it's a shortcut for incrementing a value stored in a variable counter. So now we have conditional loop with while again, while the number is less than 0. So this particular block will keep on executing. I'm again not sure whether while is an expression. Okay, so you can loop through a while index. Okay, so I was assuming that something on the lines of for each, but it's simply just incrementing the index plus and checking if index is greater than the last value and then exits. So you can just run this here itself. All right, so we have all the all the values printed here. Hmm. So this is what I was more interested into. So I will create another function, func, sorry, it's fn loop array something. Not sure how common it is to use a sneak case here. So you can loop through there. It's never used, so I'll just call it here. Loop array. So I'll first define an array. 1, 5, 8, 9, 89, 78, and 0. Semicolon is required. Now says that we can use for loop. So syntax is for. This is the variable store that you associated in this particular index. So this is for, and then the value and in array. And again, we have used macro. Let's run this. The value is 1 for 49, 70, 89, 78, 0. So that's fine. I'm not sure how to get index in this one. So to have key, I guess, well, I'm not sure. We cannot. So that's for range in Golang, we also get index for this particular collection apart from the value. It was true for arrays, slices, or maps as well. Yeah, so this also helps. So here, if you see that along while we also have to kind of check for integer overflow or the index overflow, but here this also we not need an additional check. It automatically terminates once we are out of the index. Yes, it provides a safety and conciseness for results. So they're safe and concise as well because it does not have any other addition. So here the while what we have to do, we also have to provide a check, also have to do encryption. So these two is abstracted from the user in for value and so that's fine. So we also have a range operator here. So this range, I know what is REV. Oh, we haven't yet talked about it. Okay, so we can have a range and we can also have reverse range. So probably 1 to 4 and then it's the reverse order. Where is 1 not? Okay, this we got 3 not. Okay, so last one is not inclusive. So 1, 2, 3. I guess that's also use that reverse range reverse. So I'll create another function for range reverse, range rev, and just call this here. Alright, so this 4 is exclusive and REV will reverse I guess we can have some interesting problem using this, but we'll do it maybe in the evening. But right now, the looping we just saw was about a simple loop. You can also, and the loop are expressions. So whatever is the last last expression that got evaluated is written by this loop, and that can be assigned to a variable. We also saw while. Okay, this is for the while. Okay, I've not copied it, but there is a while similar to any other programming language. It will while an expression till the time that the expression is true. The while will execute code block inside this, and then we have a nicer way to iterate over the values of an array using for and for this will value that we are at particular index, and then we also saw about how to for again in and for range, and we can also use dot rev to get the reverse of this particular range. Can we have just numbers? Can we have A to Z? No. Well, let's see that. Oh, it's not found. I guess we should also start looking into documentation. Now we are starting to get a bit more comfortable, so it doesn't have so it seems like it just works on the numbers. Fine. Alright, so this we have some exercises over here. I guess this one we can try to implement later in the evening. Right now I'm feeling a bit hungry, so I will probably grab my lunch. And after the lunch, I guess in a couple of hours, it will take some hours. We can try to implement these small applications. Temperature between Fahrenheit and Celsius, that should be easier. And it's Fibonacci number, and print the lyrics to Christmas Carol. 12 Days of Christmas. I'm not sure about this song, so let's see. And lyrics. The first day of Christmas, my true love sent to me. So these are repeated to the ah all right. So this is nice. So every day you are just adding more elements. So first line is common, second line is so it's kind of a collection, and every day you are adding a new entry to the collection or the array, and every day you are so that's nice. Oh, the 12 was running out, so this is good. This is nice. Alright guys, so this is it for the stream. The day probably we will be connecting back later in the evening, and we are going to do or work on the exercises that are given on the spoke. So have a nice time. Meanwhile, continue coding, continue learning. Bye bye.